Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on similar triangles. So we learned in a previous video that two shapes are similar if pairs of corresponding angles are equal and pairs of corresponding sides are in the same proportion. When we're dealing with triangles, things are a little easier because we don't need to check every pair of angles to see whether they're equal, and we don't need to check every pair of sides to see if they're in the same proportion. Instead, we can use one of four tests. We apply the tests to the triangles, and if they pass one of these tests, then they are similar. So let's look at these two triangles here to determine whether or not they're similar. So I have all the side lengths. So the scale factor here, remember, it's the side in the larger shape divided by corresponding side in the smaller shape. Longest side divided by longest side. So 14 divided by 10 is 1.4. But also 11.2 divided by 8 is 1.4. 7 divided by 5 is 1.4. So what's happening here, each side in the larger shape is 1.4 times its corresponding side in the smaller shape. So that means that the sides are in proportion. So it turns out for two triangles, if all their sides are in the same proportion, then they must be similar. So we call this the Sss test. S means pair of sides in proportion. We have three of them. 3 pairs of sides in proportion means that the two triangles are similar. So I don't need to go and check the angles. I just know that these two angles will be equal, so will these two, and these two will be equal. I don't need to check anything about angles. These two triangles are similar. So let's look at the next two triangles over here. So again, we have sides in proportion because 20 over 15 equals 8 over 6. If you put both in your calculator, you get 4 over 3 or 1.3 recurring. So that means the sides in the larger triangle are 1 1/3, 1.3 recurring times the corresponding side in the smaller shape. Similarly for here. So here we don't have all 3 sides in proportion, but we have 2 pairs of sides in proportion. We also have that the angle between them is equal. So this is the Sas test. So here A stands for pair of equal angles, and for the S's, pair of sides in proportion. So you need to be careful with this test here because it's not any 2 pairs of sides and any angle. It has to be 2 pairs of sides and the angle between them, like here. So make sure you remember that. So let's look at these two triangles here now. We don't have any information about their sides. We do have 2 pairs of equal angles. Now, if you have triangles and they have 2 pairs of equal angles, the third pair is also equal. That's because the angles in any triangle add up to 180 degrees. So this missing angle must be 80, so the angles add to 180, and this must also be 80. So it turns out if you have 2 triangles and they have 3 pairs of equal angles, they are similar by what we call the AAA test. So of course that means 3 pairs of equal angles. Now what we're saying here is that if 2 triangles have 3 pairs of equal angles, we don't need to check their sides. We know that their sides will be in the same proportion, and these two will be similar. All right, let's look at the last pair of triangles. So this last test is one that you can only use in right-angled triangles. It's called the Rhs test. So R means right angle, so they have to have a 90-degree angle. H means hypotenuse, and S again means side. So it means that the hypotenuses and another pair of sides are in the same proportion, and both also have a right angle. So here, the 2 hypotenuses and the pair of other sides are in the same proportion because the scale factor is consistent. It's 1.5. So the hypotenuse in the larger shape is 1.5 times the hypotenuse in the smaller shape, and the other side 1.5 times the side in the smaller shape. So you've got those sides in proportion and both have a right angle. So these two triangles must be similar. We know that the third pair of sides will be in proportion and that the other pairs of corresponding angles will be equal. So knowing these four tests, what we will do is we'll be encountered with pairs of triangles and we'll see if we can apply one of these tests. If we can, the triangles are similar. So we will go through each of these pairs of triangles and see if we can apply one of the tests. So for these two triangles here, we have no information about angles. So let's try and apply the Sss test. So 8 over 4 equals 6 over 3. So these two sides, this pair of sides and this pair of sides, are in the same proportion. The scale factor is 2. But the longest side of each shape is not in that proportion. 11 over 4.5 does not equal 2. So the scale factor is not consistent. So therefore, this pair of triangles fails the Sss test, and that means that they are not similar. It means the second shape isn't just an enlargement of the first. So let's look at these two triangles here. So they're both right-angled triangles, but I don't want you to just think that because they're right-angled, you must use the Rhs test. You see, here we have two pairs of sides in the same proportion. They're in the same proportion because 15 over 10 equals 12 over 8. Both are equal to 1.5. So the scale factor is consistent between the pair of sides. But this angle is the angle between the two sides. We can't use the Rhs test because we don't have the h, the hypotenuse. So these two triangles actually satisfy the Sas test, therefore they are similar. So let's look at this third pair of triangles here. So once again, we have two pairs of sides in proportion. 12 over 6 and 10 over 5 are both equal to 2. So the sides in this shape here are double the sides in this shape here. But the thing is, we don't have the angle between the two sides here. We do in this triangle, but not here. And that's what we have to be careful with the Sas test. We can't just say that these two are similar because they have two pairs of corresponding sides in the same proportion and an equal angle. To use the Sas test, we need to have this angle in between. Now, we can't use any of the other tests. The AAA test won't work. We don't have enough angles. We can't use SSS because we don't know these two sides, and we can't use RHS because they're not right-angled. So here, we actually don't know whether or not they're similar. We can't tell. We can't use the Sas test. That doesn't mean they're not similar. It just means there's not enough information. So let's look at these triangles in the last shape here. So what we have is we have a big triangle and we have a smaller triangle inside. We have no information about sides. So the only option available to us is to use AAA test. Now these two triangles do satisfy the AAA test. This angle here is common to both triangles, so it must be equal in both triangles. If it's 30 degrees in the smaller triangle, it's 30 degrees in the larger. So this angle and this angle are equal because they're corresponding and we have parallel lines, and similarly these two angles are corresponding. So these two triangles are similar because they satisfy the AAA test. So the last thing I need to do is write a congruent statement. So I'm going to give these vertices names here. So this is how we write a congruent statement. So we start off by writing triangle, and I can call the first one whatever I want. So this one here I'll call ADE. Triangle ADE. Now similar is this symbol or this. It doesn't matter which you use. Now when we're writing the second one, we have to be careful. If I wrote A first for the first triangle, I need to write first the vertex in the second triangle that corresponds to A. So in the large triangle, A corresponds to itself. The angle at A is equal in the smaller triangle and the larger triangle. So that's pretty simple. But because I wrote D second in the smaller triangle, when I'm writing the larger triangle, I need to write the vertex that corresponds to D, and that's C. I can tell because they have the same angles there. So D corresponds to C and E corresponds to B. I need to write them in this order so that the first two vertices correspond, as do the second two and the third two. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.